Hello. This module will give you an example on how satellite data can support public administrations when they have to perform checks related to the eligibility of farmers for EU aids in agriculture. Local and regional authorities may be requested to clarify the position of some farmers whose eligibility to receive EU aids is in doubt, in compliance with the European Council Regulation number 2078 from 1992. In particular, in Italy, each regional authority has adopted the EU regulation and has established specific measures for regulating EU aids for farmers. Measure F, in particular, regulates the so-called set-aside procedures to help reduce the large and costly surpluses produced in Europe and to deliver some environmental benefits coming from a reduction of intensive agriculture. According to such regulation, only farmers who actually set arable lands aside for a specific temporal period may be eligible for receiving EU funds. Satellite Earth observation data may be used to check the actual presence of arable lands before the farmer actually applies for the EU contribution. Landsat data can be usefully employed to this aim. In fact, they have the right trade-off between spatial resolution, for example 30 meters, and temporal repetition rates, for example 16 days, together with offering more than 30 years of records for identifying and monitoring land cover changes during the last decades. Sentinel-2 builds on this legacy with a resolution that is a bit higher, 10 to 20 meters for the optical bands, and a revisit rate of 5 days when both Sentinel-2A and Sentinel-2B will be operational. We used the normalized difference vegetation index known as NDVI. It is a measure of the vegetation such as content, status, and health, which is present within the image pixel. Different land covers have typical NDVI annual patterns, enabling to discriminate them. The difference in NDVI maps, computed in 2 different periods, will help to distinguish arable from non-arable lands. This demonstration will describe the step-by-step process, and namely how to compute the difference of NDVI in 2 different months of the year, generate a Boolean mask, and thirdly, verify the result on specific selected areas. To this aim, we will use the Quantum GIS, or also called QGIS, a free and open source software, Landsat or Sentinel-2 NDVI images of selected periods. This slide shows you all the files that are provided for applying this module. Landsat NDVI TIF files concerning month 1 and month 2, as well as shape files with example of arable and non-arable land. The next video, which we will be launching soon, is going to show you how the derived bitemporal vegetation maps can be practically used to generate binary masks of arable and non-arable lands over specific areas of interest. We will now start the video. We will start by opening QGIS, and the first step is to browse, select, and open the NDVI imagery. Then the difference between the 2 NDVI maps computed in 2 different periods of the year is calculated using the raster calculator function in the QGIS. A new window will open. On the right, select the output folder and choose the output file name, NDVI difference. Select the first raster image. Select the second raster image and finally press OK. Having the NDVI difference file, the Boolean mask should be created, identifying areas showing positive or negative vegetation changes in the 2 selected months. Similarly, the raster calculator function is used and the results is written in a new output file, which we will actually call Boolean mask. We are now showing how to set the Boolean mask values according to positive or negative changes in vegetation cover. In the raster bands workspace, select the NDVI difference source file, and it will appear in the raster calculator expression workspace. Thus, use the operators to set the tests and the thresholds to be applied to NDVI maps, as shown in the video, and then finally, you can press OK. Now we want to check what the situation is within the specific areas we are interested in. Thus, open the shape file representing the polygons of the area to be checked, specific parcels where applications for EU aids have been requested by farmers. And these are vector layers and have to be added in QGIS as shown in the video. Select in sequence the shapefiles for arable land and non-arable land. Now the parcels that should be checked for their eligibility are superimposed to the Boolean mask, and you can verify if within these areas arable and non-arable lands were present at that time. You can select each shapefile in the layer panel and zooming over the area of interest. According to the chosen tests and thresholds in the Boolean mask, the value 0 depicted in black means arable land, whereas the value 1 in white stands for non-arable. As a result, on each area of interest, you have information about the presence of arable or non-arable lands. So the demo here presented refers to a use case in Basilicata region in the south of Italy. The methodology was designed by the University of Basilicata and is implemented by Geospazio Italia, which is a local SME. It is portable on different geographic areas. Landsat data were used here to demonstrate that Earth observation data may be profitably employed to check farmers' eligibility even after several decades. For more recent uses of Copernicus data, especially Sentinel-2 imagery, may be usefully employed with more valuable results, thanks to its improved spectral, spatial, and temporal resolutions. I thank you for your attention.